All right, welcome to part two of our lectures on strings and character handling. I forgot to mention in the last lecture, but in the book we're on to chapter 8, and there's quite a bit in this chapter, so you don't have to certainly don't have to read the whole thing. I would just suggest if you want to read section 8.2, skim through 8.3. You can skim through 8.4, 8.5. You'll find FGITs and scanf and scanf, so some of those things that we'll talk about today. 8.6 has string copy or strcpy. That's another function we'll talk about today. 8.7, and that's probably all you really need to know. The rest of it, 8.9 is memory functions of the string handling library. We're not going to use any of those this semester, but they're certainly there if you're interested in it. I highly encourage you to read the entire chapter, but because it is a large chapter, I just wanted to help provide you with a little insight into, kind of how to focus down and just read about the things that we need to know about. So with that, we'll move on. The last lecture we talked about strings and character constants and characters, and that strings are really just char arrays with a null term, with char constants, character constants as the values, and then a null termination character at the very end. So with that now, I just want to talk a little bit more about how we work with strings. All right. There are a bunch of functions. There's the string.h, that string header file, with a bunch of functions that we can use. And so at this point, if you can find a function to make your life easier, then by all means use it. Okay, I'm not in the string lab. There's string length, there's ways to compare. If you can find it, use it. There's certainly there at your disposal. In general, though, I want to look at just a few, just to throw a couple of them at you, look at their return types, and then look at their naming convention as well. So when we talk about functions, we talked about a little bit here at the introduction or the review at the beginning of the course, as well as in 150. What we name our functions is really important, because we should be able to look at that signature and tell a little bit about what that function is going to do. When we look at this first block of functions here on the slide, so is blank, is digit, all the way through is upper, you can see there's two things I want to point out in particular. One, and the first thing is the return type. Okay, the return type there is an integer value. Okay, natively we don't use booleans, boolean being a true or false value in C. We just use 0 or 1, or 0 or anything that's greater than 1. Well, that's true with these functions, and you can see on the right hand side of that, with each line I say, for is blank, true if C being the value of the argument, is blank character, false if not. All right, so the other thing I want to point out is how do they name the function itself? They use that word, they prefixed each one of those functions with the word is, and that is a very common way of naming a function that returns a Boolean value, a true or false value, whether it actually returns true or false or it returns 0 or 1. If it helps you, you can certainly use Booleans in your programs. There's I think it's bool.h, it's a header file, and they're just symbolic constants that then get replaced with 0 or 1 in your program. So if those would help you, though, let me know, and I can show you how to get that set up, and you can use Booleans instead of using 0 or 1. But that's really all we're looking for. 0 is false, 1 is true. All right, so in here, you can see that those functions then are looking for true or false. You're providing it a value, it's comparing it against something inside the function, and then returning whether it's true or false. So at some point in time, if we need to look at if a character is upper, is lower, we can use these functions to help us out. With the bottom two functions, okay, these are just a sample. There's plenty more functions here. I just wanted to point out a few. We have 2 upper and 2 lower. Okay, so in this series of functions, they prefixed it with 2. And that means that we're going to transform that character into something else if it isn't already. All right, so the return type on those is integer. Okay, character constants they represent a numeric value. They represent something, a character out of that ASCII table. So however those characters map up to those ASCII values. So if I call the 2 upper function and I provide a lowercase number, or a lowercase character, then it'll return the numeric value that represents the uppercase. So for lowercase b, it will return the numeric value for the uppercase b. Okay, same thing with 2 upper. The point, something you got to keep in mind, we'll look at these here, this example here later on in the program. Just something you got to keep in mind is that these return the value. Okay, so if you want to change or transform a character and it's a character in an array, then you have to assign the return value from that function to that element in the array. Okay, and we'll look at that here in just a minute. With that, we're also going to look at some standard input and output functions. Okay, I talked about just a little bit there at the end of the last lecture on string introduction, scanf, and there are some limitations for scanf. So scanf works if you don't need a space. That's the big limitation, is that if you want to input something like a sentence, oh, you know, I take that back. I didn't. So we're going to talk about, I'm sorry, I got a little bit ahead of myself here. We're going to talk about, I took it out of the slides. It threw me off. We're going to talk about some limitations on scanf. And so we'll start with that. And the problem with scanf is that scanf, it stops reading input from standard in when it encounters a handful of characters. And I have it written down in the code, so we'll see those exact, but I think it's end of file, new line, tab, or space. Okay, well, a space is a big deal because if we want to enter in a sentence, then we need to be able to accommodate, we need to be able to allow that space character in. Okay, so sometimes scanf is going to work if you just need a single word, a single string value with no spaces in it, or any of those other characters that it stops reading input from. If we need those characters, if we need tabs, or for at least for the purposes of the next lab, we need spaces, then we need to use a different function. In this case, I'm going to introduce to you fgets. There are other functions. There are certainly better, more secure ways of getting input, but for the purposes of just exploring the fundamental, the core computer science topics here, we're going to stick with just these two functions. So fgets, here is the function. Okay, the return type is a char pointer. Okay, and we haven't really talked about pointer return types yet. So don't worry too much about that. When you see how this is used in the code, I think you'll be fine with it. It has 3 arguments, and this is a little hard to see. This was kind of a poor choice using it here, putting it in the slides, but we'll go through the definition and usage in a sample program. So what we do here, this first argument, we just need to provide a string. We need to provide a char array or a pointer, wherever we want to store the input. That's all we're doing there. The second argument is int n, and that is the size. Okay, so if we have a char array of 50 elements, then that would just put in 50 here. And then this last one, and this will make a lot more sense once we go through the lectures on file I/O, but we're just capturing input from standard in. So we'll just type in stdin, that's all we have to do there. So the second function, get char, we're not going to cover it. You can look it up. It just takes a single character from standard in. We don't have any particular usage for it. So I mean, if you come up with one in your programs, that's great, use it. But at this point, it's not necessarily important. We're also going to look at, let's see, we'll look at string compare, string length, and string copy as well. Okay, they're all pretty straightforward, and so we won't spend a ton of time on them, but you probably will find occasion to use them here in your programs. So with that, let's go to the code. Actually, I'm going to pause for just a second. Okay, sorry for the abruptness there. I just needed to make some adjustments to the code before we continued. So I want to make sure that we cover all the topics. Again, I want to cover all this because you may choose to use it to solve the lab. Okay, I'm not necessarily, I don't typically do labs. It depends. When we get towards the end of the semester, I will, where I say you will use string length or you will use 2-upper. And in this next lab, in the string lab, you will use 2-upper and you will use 2-lower. But not everything. So I just want to make sure I cover it all, though, so you have a good foundation on strings. So let's take a look at this code, and we can see here that this is the similar loop from the last code that we looked at, so the original program on our string introduction. And all this did was we declared an array or a string 4. I give it a value, assigned a value of test, and then we iterate over that. Our condition is to iterate until we find the null termination character, and I'm printing off the character and the numeric value. So I'll just run that real quick. Oops. All right, so similar output to the last program that we looked at. now I want to look at some of those first functions, that 2 upper and 2 lower. And what we'll do is we'll make this modification here. Okay, so I'll comment out those 2 lines of code. You can see here's our call to 2 upper. The argument for 2 upper was the character that you want to convert to an uppercase character. If it's already uppercase character, it doesn't matter. It's just going to return the value for that uppercase character, and there'll be a negligible change to your program. If it's not, then it's going to return the ASCII value, the numeric value of that character's uppercase equivalent, and then we will assign it to that element. Okay, and then we'll print. We don't want to do that. Let's do this. Just make some slight rearrangement here in the loop. All right, so then we'll print. Oh, here, actually, I already had that done. Sorry. Let's just get rid of that whole line altogether. Right, then we'll just print off. Oh my goodness, I didn't. All right, so we'll comment that back out. I'm going to use that for a different purpose, and we'll minimize that a little bit. All right, so after we transform the case to uppercase, we'll print off the character. So compile and we run, and there you can see. Here's our output, the word test. Okay, this was all lowercase, but I transformed each character into an uppercase. Okay, so not only did I call the function, and I provided the value to the argument, which is the character that I was looking at, each character in this array individually, but then I assigned it to that array. I replaced that value in the array. I need to do that, otherwise this doesn't work. All right, so let's look through this example. Make some more modifications here. And what will this do? Well, string 4. All right, so we're going to print off each character, and I'm going to provide the return value from that 2 upper call as the value for the argument for this format specifier in the printf. I'm not reassigning it though. So what you're going to see is we're going to print each character. Okay, so let's get rid of these previous 2 lines of code. I'll just delete them. Well, no, I'll leave them in there. So we don't do any of that. Okay, we don't reassign a new value to that element. We're going to print it off. We're going to call the 2 upper function, but we're not storing that return value anymore. We're not assigning it to that element. So we'll print them off. It'll print off all uppercase characters, but then when we print the string again, you're going to see that they're still lowercase because we didn't modify any values in that array. So there's our output. Okay, each character was uppercase, but the overall character array is still lowercase because we didn't assign that value. Okay, so that's 2 upper, 2 lower, works the same way. If we wanted to check, okay, so let's see here. I'll make a few more modifications, so just bear with me here as I do that. But if I wanted to say, let's say that I changed the actual value of that string, and I uppercase the first character. And then we say if is upper string 4 and I, so we have to provide a value, then we'll just simply print uppercase found. Otherwise, we don't worry about anything. We won't generate any additional output. Okay, we know from that definition that we looked at in the slides that is upper is a Boolean. It's going to return a true or a false. If it's upper, it'll return true. If it's lower, it will return a false. So the only time we enter into this loop is if this function returns a true value. And if we run this, we can see that 1 uppercase letter was found. And we could obviously make this a little bit better for the output. We could print the character that we found, but we know because we're looking at the source code, there was 1 character. This printed 1 time because it only found 1 uppercase character. So we can use the is upper, is lower, is alpha, is, all these different functions that test a character to see if it fits or meets some sort of condition. All right, moving on. comment this guy out. Next function I want to talk about is string length. So here's the string length function. Its argument is a string. Okay, so whether it's a pointer or it's a character array, you just provide the name of the string that you want to check the string length from. So if I run this program, we'll see that it's going to give me the string length for string 4. What is, actually need that commented back in. What is the length of string 4? Well, is it 4 or is it 5? We'll find out. It's 4. Okay, so string length does not account for the null termination character, and that's good because typically we don't really care about the null termination character. We care that our strings are null terminated correctly so that our programs work correctly, but when we're actually counting the characters, we want to manipulate characters, we want to iterate over the characters, we only care about the actual, all of the characters except null termination. So string length gives us that. It does not account for the null termination character. So now if we go back into this little loop that we have, and let's change it to simply print off the uppercase. Okay, so kind of what we started off with, but instead of this condition here, we can now change that condition and say while I is less than string length for string 4. All right, so let's go ahead and run the program. All right, perfect, right? Length is 4. We need 4 iterations. We start at 0, so 0 to 3, that's 4 iterations. TEST, we have no null termination character. The length of the string is 4. All right, so that helps. And that helps because then we don't have to know. We don't have to hard code the size of our strings into our loops. We just say, it doesn't matter what size this is. This loop will work on any size string because I use the string length function to determine the size, and that therefore determines the number of iterations on my loop. Okay, now I can finally comment this out, and we can move on to some different code. So I started off talking about scanf and then realized I didn't talk about scanf yet. So let's take a look at scanf. Looks like a lot of code, but there really isn't that much. We'll move through this pretty quickly. So let's say I want to enter 2 words. Last lecture we looked at entering 1 word or one value without any spaces, and everything worked fine. But if I want to enter 2 words, we're going to have some issues. So here you can see just in these few lines of code, just prompting the user to enter words. I declare a string 6, so a char array, string 6, size 40. I use a scanf, so for %39s. Remember that when we use scanf, we want to take is we need to leave space for that null termination character. So here we have plenty of space, right? If I enter the word test with a space in between, I'm going to print that value off. We have plenty of space to do it. So I'll do that. I'll enter it 3 times. Okay, so test space, test space, test. Now when I ran that, I printed off the value of that string, and it only printed test. Okay, so as I mentioned, it's because scanf reads until it encounters a space, a new line, a tab, or EOF. EOF is end of file indicator. So in this case, if we want to input, if we want to capture input on standard in that includes a space character, we have to change what we're doing. So we look at using fgets. Get rid of this. Let's look at fgets. So again, I'll prompt the user, and I'm going to use the verbiage for a sentence because that's really what I'm thinking about here. We'll say, we'll declare a string or a char array sentence. We'll give it 50 elements, and with fgets, then all we have to do is it's fgets, whatever the name of our array, the size of our array, and then standard in. Okay, don't worry about this. stdin, standard in, that's what we're always going to use for right now. Okay, so always just type that in. All you have to do here is provide the name of the string, the name of the char array you want to use, and the size. Okay, fgets will handle the null termination for you. So you don't have to worry about null terminating. You don't have to worry about, well, I declared an array of size 50, but so I need to do 49 to save space for that null termination character. Don't worry about it. fgets will do that for you. So it's the same size. And now, once fgets executes, it's just like scanf in a lot of ways, is then it's looking for you to type things on the keyboard from standard in, and then it'll stop capture on that new line when you hit enter. From there, it saves it into the sentence variable, so our sentence array, and now we can do stuff with it. In this case, I'm just going to simply print it off. Okay, and we'll run it. Enter 2 words. So test, I can enter as many as we want. No, see, I forgot to save again. Or I did, I just didn't push the buttons hard enough. Okay, so we'll try that one more time. Should have caught the verbiage change there. Enter a sentence. So let's do hello world. You entered hello world. Okay, so there you can see it. Caught it, captured all my input, captured the space, and now I'm happy. So 2 ways we can capture input from the user and capture strings. That is, we use scanf or we use fgets. Remember, if you want to capture or allow for spaces, then you need to use fgets. Okay, this is how you use fgets. Now, I want to point out one interesting thing. You may or may not encounter this, so hopefully this helps you out just in case you do. And you can see here that I'm going back and we're going to have scanf and then an fgets. Okay, so I'm going to use a scanf before I use an fgets. So we'll compile that program and then you'll see what happens. We'll enter 2 words. All right, so what happened? The program completed. It finished, it terminated. It didn't stop and prompt me when it got to the fgets code. So there is a problem, and we don't need to go into the details. If you're interested, I can tell you exactly what happens here. But suffice it to say, you can't use scanf before you use an fgets, and that's based on how scanf captures input from the keyboard. Okay, remember that when we're done entering input, when we're using a scanf, we hit enter. Enter generates a new line. What happens is that new line gets left in the buffer. So when fgets goes to read from standard in, there's this new line character still in the buffer, so it executes as well and doesn't capture anything. All right, so again, the bottom line is you can't use scanf and fgets at the same time. So if you try to do that in your program, you're going to run into issues, and that's why. So just keep that in mind. There's ways to solve it, so if you're really interested, I can help you out with that. But again, for the most part, don't worry about it. Just know you can't use the 2 together. You can't use scanf before an fgets. All right, last couple things, and then we'll wrap this up, is string copy. Scroll down a little bit. So in the first lecture, I said there's some things that we can't do, and one of those things is this right here. Okay, if I declare a char array string 7, and I don't initialize a value or something useful right away, then I want to eventually assign something to it. Well, I can't do this. Okay, the value of the variable when it's declared as an array it's a pointer, it's a memory address. So you're going to get an incompatible type when you do this. So in order to assign a value to this now, after I've declared it outside of the declaration, I need to use string copy. String copy has 2 arguments, the destination and the source, and that's all it is. So where do I want to store this string? In this case, I have a char array, string 7. I want to store it there. And what do I want to store? I can use a string literal. I can use another string. I can use another char array. I can use a pointer. It doesn't matter. What matters is that it's ultimately a string. So I'm moving it from here, and then I'm storing it into here. All right, and then we can print that off, and you can see that the value of string 7 will now be hello world. And there we go, hello world. Okay, so that's how we use string copy. strcpy, destination, source. Both of these values have to be strings. And by that, like I said, it's a string literal, this has to be either a pointer or a char array. This can be a string literal, a pointer, or a char array. All right. And the last topic we're going to look at is comparing strings. Okay. Now, comparing strings for us is pretty straightforward. If we look at these two strings right here, then I can see the blue is not equal to red. So there's a function in C, one of those helpers. It's strcmp. Okay. What do we provide? It has two arguments, and it's just the two string values that we want to compare. So we provide those values here. In this case, because I want to compare these two pointers, we're providing those two values. Now, for the most part, I think you probably go string compare. It's true if they match, it's false if they don't. I think that's a very logical thing to assume. So that's how I have this condition set up. If string compare returns true, enter this branch and print off they match. If it returns false, we don't enter that branch, we enter the else branch and we print off they do not match. So we're comparing blue versus red. Those actually have the value blue versus red. Let's see what happens when I run the program. It says they match. And this is definitely not true. And so we didn't run exactly how expected. So the thing to know about string compare is that it returns 0 when they match. It can return a number that's greater than 0 or less than 0. And it's not important for the course, but why it does that is because it actually looks at, and I forget which way it actually compares, but it looks at them alphabetically, and it'll tell you if one comes alphabetically before the other, based off of that return value being less than or greater than. So in this case, all we care about is that if they match, string compare returns 0. So in this case, then I'd want to modify my condition to say if string compare returns 0, if the return value from string compare equals 0, then I know they match. Otherwise, they don't match. See, and there, that's what we'd expect. They do not match. So now if I change that to red, now we're comparing red to red, they match. And that's what we would expect. Okay, and then just to show you, here I decided to use pointers, just so you saw some of the other ways of declaring strings that we've talked about. But I could use char arrays as well. So we could provide string 1 and string 2. And they match. And they do, because the value is test and test. All right, so that's everything as far as some of the more advanced functions. We'll be using strings kind of off and on now throughout the rest of the semester, so please take some time and get to understand how to use them and all of these additional functions that we use to help: string copy, string compare, 2 upper, 2 lower. If you have any questions, as usual, let me know. I'll be providing the practice labs. In fact, if you go and take a look at the slide deck, the very last slide is the practice. So this will be the practice lab. And if you want to work on those, let me know, or start working on them and send me your code, because I'll be more than happy to provide you with feedback. Same with the labs though as well. So anyways, that's it for strings. Thanks a lot.